My name is Marcus Purdy. This is a projectile motion function demonstration written in MATLAB for Engineering 267. Let's take a look at the function. It's called projectile. Here's the help file. The inputs are initial x position, initial y position, initial velocity, launch angle, and a plot flag. 0 gives no plot, any other number gives a 2D plot. The outputs are arrays that log x position data, y position data, velocity data, and time data. The inputs are limited arbitrarily so that I can scale a sampling period with a structure of if-else-if statements. Also, use some if-else statements to auto-scale the axes so that they're of equal size when plotting, giving accurate representation of the trajectory path. A while loop fills the data arrays while the height is greater than 0. When the trajectory hits the ground, the while loop exits. When plotting, a for loop animates the trajectory path. I guess that's about it for details. Let's call the function. Let's start at the origin with 150 meters per second initial velocity, say 45-degree launch angle, no plot flag. Let's just get some data. Here we see the data I described earlier. Let's take a look at the same trajectory graphically. We have distance, height in meters, little title, no big deal. Let's look at the same trajectory, or let's look at a graphic trajectory. 75-degree launch angle, maybe 50 meters in the air. So we're starting a little higher up. That's represented in our data here. The height gained is less than the maximum height. So let's take a look at our error handling. So yeah, got it up to 200 meters per second. That seems reasonable. Let's call it one more time, then we'll do something else. Let's say we're 200 meters forward and 500 meters in the air, and let's just go to the max and say pretty steep trajectory with a plot flag. So yeah, we're really getting pretty high up in the air here, above 2,500 meters. Well, that's probably enough for calling it one at a time. Let's use a for loop to plot 3 trajectories on one figure. Specifically, we'll plot a 30-degree, 40-degree, 50-degree launch angle. 150 meters per second, going pretty good. Let's just say 10 meters off the ground. I don't know, standing off some kind of launch platform of sorts. In any case, let's evaluate this script. Here's the first trajectory. The data is represented here. Start of the second trajectory's data is here. And finally, the third, and it's illustrated here in this figure. That's about all I can think of. Thanks for watching.